Obviously, the need to make airplanes aerodynamic means getting components isn't always convenient. For example, this 767's jack screw, now that's the part that raises and lowers the airplane's horizontal stabilizer, is only accessible through this tiny door to what maintenance professionals lovingly call the hellhole. There's the jack screw up there. This space is also home to the pressure bulkhead. It's that dome that helps ensure the cabin remains pressurized at altitude. When maintainers need to work on the electronic components of airplanes, they often enter through a tiny door like this one near the front of the fuselage.
Here I am coming up into the electronics compartment of this 767. This is a part of the plane you really never see.
These components are all modular, allowing them to be easily swapped out if there's a problem or need for routine maintenance. Also, look how carefully these miles and miles of wiring are handled. From there, we were also able to access the cargo area. And like most of the spaces we visited on board, it's cramped, but perfectly suited for its job. These rollers and locks ensure cargo doesn't shift in flight. And no visit to an empty jet can be called complete unless you check out the cockpit. But as I looked around at this massive machine and the others parked throughout these hangars, my mind turned to the parts. I mean, maintaining these planes surely takes a ton of parts and pieces, tools and components, and it's not like you can just run over to Home Depot to grab what you need. So, where do the new parts come from? And when they get here, how are they sorted and checked? For that, let's meet Malcolm Myers for an overview of how new parts are received here at Tech Ops.
We take material, we move it through our process as quickly as we possibly can in order to make it serviceable for mechanics to get the inventory to the aircraft as soon as possible. It's a very fast-moving operation where we are basically trying to get material on its way, right? This is not a holding place for material. This process right here is not for any material to stay here. It's to get received in, ready for serviceability, or ready to be sent to a shop for further repair or serviceability. But this area right here allows us to navigate that material on its way. This is the main hub, and you're going to get basically 85 to 90% of all of the new parts coming through this process.
Once those new parts and materials are received, logged, and quality checked, they have to go somewhere. And that's where these bins come in. An automated system can pick any part in a matter of only a few seconds before it's ready to be delivered anywhere in the Delta system, as in pretty much anywhere on Earth.
If you think about the number of pieces and parts that are required for an operation like this, it's overwhelming. So back here in this section, there are probably hundreds of thousands of parts stored right here, and they can access them in almost no time when they're needed out on the floor. Pretty incredible.
Delta has exacting standards, which means not every part they receive is accepted. And when that happens, they go here.
Hey look, it's my second home.
In addition to that main warehouse, Delta operates a number of smaller facilities throughout Atlanta with more frequently needed parts like fasteners and even safety cards. But it's not all about new parts. Delta has a number of departments focused solely on refurbishing components.
So there's so many different parts and pieces that Delta really goes out of their way to repair them right here at Tech Ops. And the reason for that is because if they were to go out and buy new parts, it'd be inordinately expensive. But not only that, Delta's able to maintain the quality of those repairs right here with these professionals who do, as we've seen so far, an incredible job maintaining these aircraft.
One such department is the hot section shop, where I discovered the mesmerizing low vacuum and low pressure plasma thermal spray process. It uses a plasma process to clean parts before they're checked to see whether they need additional repairs. But its operator, Bobby Pike, has a much better name for it.
AKA flux capacitor. It's designed to clean the car in zero atmosphere pressure to eliminate any oxidations and impurities in the metal.
That's just one of the many steps taken here to ensure parts operate at their peak. Others in the hot shop include furnaces that heat parts up to thousands of degrees for hours at a time to ensure they're completely clean. And once they're clean, some parts need to be coated with special materials. For that, we turn to Phil Bennett.
We work on small engine parts over here, and then small engine parts. That's what we do. We do like full valves, hanging gears for the engine. We bring them in, say after a chrome strip, we tape them, we do all the research,
shop filled with its vats of bubbling chemicals reminded me of my high school chemistry lab, only if it were on steroids. One thing I do recall from chemistry was that it often smelled bad, but they have a clever solution to reduce those smells here. They use these balls.
Put those balls in there to keep the smells down. Otherwise, this place will leak.
Some of the parts are even silver-plated because that's what they require to operate most effectively. Now, when it comes to tech ops, as critical as warehousing and cleaning, coding, and machining parts is, equally vital is ensuring the quality of that work. And there are a number of ways it's done. For example, there's this 3D structured light scanner, which is a rare piece of equipment for an airline MRO to operate. But Delta uses it because it speeds up their ability to find potential faults in parts. They also use magnetism and fluorescence to look for invisible problems in components. For more about that, let's turn to Andrew Dodson.
Okay, so this is our magnetic particle inspection room. This is one of our older machines. We have two areas in which we do mag particle inspection. It shoots a current through the part. Now what that does is it creates a positive and negative field along any imperfections in the parts, depending on which way we shoot.
But that's not all. They also use temporary coatings and black lights to find parts with imperfections that are otherwise imperceptible.
In this particular spot, they're using all kinds of technology, everything from X-rays to eddy currents to ultrasonic testing, to make sure that parts are as safe as they possibly can be. This is a borescope to look inside for any cracks in the turbine blades. Absolutely incredible technology.
But what if they need to replace a part they simply can't get? Enter Mitch Wright and the additive manufacturing team, colloquially known as 3D printing.
So one big thing with additive manufacturing is really kind of cutting down on time when it comes to assisting the shop. So whether that be tools that the shop needs, whether it be, when I say tools, that could be tools that are used for shop painting, it could be tools that are used for masking, it could be tools that are used for specific operations on an engine, where it may be difficult to get to a certain nut. We can then take the ergonomics into account, look at, what could we design that could help the mechanic actually work on this more easily. A big part as well is that a lot of our training, especially flight attendant training, has to be done in an aircraft fuselage that is exactly the same as the fuselage we're going to be working on. If it's a 321, it's a 321 environment that has everything a 321 would have on it. And that includes a real telephone. The problem is when you're going through training, a telephone may fall on the ground and break, and then you have to buy a new one. That new telephone can be multiple thousands of dollars. But that phone itself, it's not on an actual aircraft. It doesn't need to meet all the requirements. So we're able to print a replacement for that phone at $10 instead of multiple thousands of dollars, and not wait 2 months to get that phone. It's literally, we need one, 2 days later you have it.
It's not just plastic. I mean, this piece right here is metal. They can print metal as well.
Tech Ops does not just focus on individual parts. Complex components also need repair. So let's meet Tammy, who works to fix critical cockpit components like this audio selector panel.
It's a switching unit basically for the radio systems, and it basically directs, these are mic buttons that allow the pilot to talk, and these are the ones that allow them to listen, and you can adjust volume and stuff, but when they go bad, we fix them. No, it's not a bad unit. They're very hardy. They're usually the first thing pulled because it's the easiest to pull off the aircraft and check.
Every shop we enter just served to remind me how complex airplanes are. From seats to windows, from coffee makers, ovens, all of it is serviced here. In fact, Delta's so good at this work, other airlines from around the world contract their work to these professionals. But let's turn our attention to the components that are, perhaps, the most mission-critical and complex: jet engines. And their complexity is probably why so much space here at Tech Ops is dedicated to keeping them running safely and at optimum performance. There's a lot that goes into these motors.
You don't really think about how complex an engine is, but they do here. In this facility, engines are disassembled, repaired, and then reassembled before they're tested to make sure they're safe. These things are incredibly complex. But here's something that kind of boils it down. The air that flows in up there is minus 50 degrees below zero. It's 50 degrees below zero. By the time it gets to about here, it's 500 degrees.
At TechOps, fan blades and compressor blades are ever so carefully removed. Parts are uncoupled from each other, and everything is sent out to various corners of this facility for testing and, if necessary, repair. And here to talk about the kinds of stresses these engines will be under when they're back in the air is Rodney LeMay.
Alright, what we're looking at here is the compressor part of the engine. We call it the compressor because what it basically does is that the engine pulls in the air with the fan blades up front. It starts to compress the air. As you can see, each different stage gets smaller and smaller. So imagine the size of a plane this big, getting down to something this size. There's a lot of pressure in that area.
Engines also have mechanical brains called gearboxes. They link the engine to components like the starter, pumps for hydraulics, fuel, and oil. Even the electrical generators, which power everything from the flight systems to your own seatback entertainment, not to mention the engine electrical power from a small generator that powers the fan. Another system. Needless to say, the complexity is overwhelming. And behind heavy doors like this is where it all comes together. Inside engine test cells. These cutting-edge facilities allow TechOps professionals to safely test engines on the ground. Delta is home to the largest engine test cell in North America. Let's go check it out.
So I've got the air up here. These are actually problems that go on the engine before it goes to the test cell to simulate the airflow around the engine as though it were an airplane. Makes it a more accurate way to measure how the engine's running.
And here to tell us a little bit more about what happens in here is James O'Brien.
We test engines for Delta Airlines and Rolls-Royce. When they come back from the engine shop, we need to run the physical parameters, make sure they make thrust, they make oil pressure, they make this vibration. We test for these different angles. That room right there that you see on the screen is actually on the other side of this wall. About 2.5 feet of concrete, reinforced concrete. Keep us safe. That engine can produce about 78,000 pounds of thrust while we test it. Itself capable of 150,000 pound thrust engine, but it's not in service right now. They go that high. We're there. We can do it. They come up with it.
Everything I'd seen that day came together when we had the opportunity of a lifetime. You see, this engine, capable, as James said, of 78,000 pounds of thrust, had reached a point in its test where it was idle. And we got to enter the test cell. The sheer scale of what Delta TechOps does here became self-evident. It was so loud and frankly beautiful, even at idle, and even with our hearing protection on. I mean, just listen to this. But it really is the people who make it all happen. I asked many of the people what it's like to work here at Delta, and the comments were consistent and unanimous.
Delta has provided the opportunity for me to grow as a professional. I did not think that I'd be doing this. And here I am 11 years later doing something that I love to do.
It's a great company.
Yeah.
One of my coworkers called it the Crystal Palace.
Good family, people, and take care of you.
It's a great place to work.
To learn more about TechOps, there's a link in the description below. And if you're interested in joining the team, you'll also find information about jobs below too.
Spending the day at TechOps has absolutely blown my mind. I hope I've shared just a little piece of how incredible it is. Delta really has earned a lot of the credibility and the awards like this, the Airline of the Year, so well deserved, and today was evidence of why. Between now and the next time, see you in the sky. So here's a little known fact. This was actually the original name for my YouTube channel. We're the wheel and tire shop, which is really fascinating, but more than anything, I wish I could share the smell with you. You just smell this rubber. It's got a unique odor. I guess each section of TechOps has its own smell, but this is the first one I'm really noticing and liking. Hello from inside the cargo area of the 767. This is a part of the plane you never see, but it's vital to making Delta Airlines TechOps work, which really makes no sense because I don't even know what I'm saying right now. balances those fan blades, runs them at 6 or 7, runs them fast to make sure that they run. That's not true, so I can't say that.